When you're first learning to graph functions, a particular kind of function, there's two things that govern your choice of the x values. One is simplicity of calculation. If you put in x equals 3.792865, the question you have to ask yourself is, why are you giving yourself something so difficult to calculate? A second consideration is, if your goal is to graph this, then you want to have values that end up being on your graph paper. And again, putting in x equals 20 million. Yeah, except do you really want to try to plot 20 million? Other than that, you can choose anything for x as long as it's in the domain, and here the domain is all real numbers, so you can pick anything. So as you suggested, x equals 1 seems to be the simplest choice because it makes that exponent be 0, and an exponent of 0 is really good. So x equals 1 leads us to 2 to the 1 minus 1 power minus 4, which is 1 minus 4, which is negative 3. Well, I don't know which problem you have, actually, but I think that you had this problem. So, a little bit of editing here. And so we have 1 produces an output of negative 4. So what about x equals 2? What do we have then? Well, we have 2 to the 2 minus 1 minus 5, and that equals 2 minus 5, which is negative 3. And nothing about these seem like it's too hard to graph, so let's just move on our merry way. Why not choose 3.1? Well, it's too hard to think about. So far, I haven't even had to use a calculator. So now I have 2 to the 3 minus 1 power minus 5, and that equals 2 to the second, which is 4 minus 5 equals negative 1. And x equals 4, that's 2 to the 4 minus 1 power minus 5, that's 2 to the third, that's 8 minus 5, that's 3. Now it seems like these numbers are getting slightly big, so when I put in 5, I'm thinking I might get something that's going to not fit on my small, tiny little graph. So it's time to start plotting these. So I have 1, negative 4, which is about here. I have, if this is our x-axis and this is our output axis, which we, instead of calling it y, we call it f of x. When I put in 2, I get negative 3. When I put in 3, I get negative 1. When I put in 4, I get 3. And so it looks like it's doing this. Now the question is, do we know anything about this kind of graph? Do we know anything about what it looks like in advance? And typically, these graphs look something like this. They kind of go flat for a while, sort of flat, a little bit of increase, and then they just skyrocket. That's called exponential growth when it skyrockets like that. So I'm guessing this is part of the business where it's starting to skyrocket. So back here, where x is 0 or negative 1 or negative 2, I expect it to flatten out. So let's go back there and find out. When we put in x equals 0, just because it's simple and because we want to explore what happens over here in our graph, we get 2 to the negative 1 minus 5. And that negative 2 to the negative 1, that's 1/2. So this is 1/2 minus 5. This is negative 4 1/2. And that's kind of messy. But at 0, this thing is down at negative 4 1/2. But notice this. As you put in x equals negative 1 and x equals negative 2 and so on and so forth, This thing right here, 2 to the negative 2, 2 to the negative 3, 2 to the negative 4, check those out. But they get closer and closer to 0 forever. And that means this gets closer and closer and closer to negative 5 forever. And this down here is negative 5, so this thing's going to get closer and closer and closer and closer and closer to negative 5. And now we have a pretty good look at our graph. It's that exponential curve. So to answer your question of why do you choose certain x's, you choose x's that are convenient for you. You can choose anything, but you've got to live with the consequences. If you choose x equals 7.92346, well, you better grab a calculator because you're going to need one to do 2 to that power. Whereas here, I managed to do this without a calculator at all. Hope this helps.